Here we have two fractions, and we want to multiply them together. You might recall that to multiply two multiple-digit decimal numbers, we just use our multiplication table to multiply one digit at a time and go from right to left, multiplying the very rightmost bottom digit with all of the top ones, then going on to the next bottom digit, and then multiplying it with all of those, adding up what we get from those two multiplications. Don't forget your placeholder 0, and we get our sum. What's nice about fractions, though, is we don't have to deal with any of these pesky decimal points. We still need our knowledge of multiplying whole numbers together, though. Back to our original problem. We start by multiplying across. That is, we multiply together the two numerators. 3 times 10 is 30. And then the two denominators. 5 times 9 is 45. Luckily, these are just small numbers, so we don't have to really do anything special. But when we get to longer fractions, you'll have to go back to our good old full long digit multiplication. Luckily, no decimal points still, though. Now we have this new fraction, 30 over 45. You might notice that this fraction still isn't in proper form yet, though. Over here, you'll see that I have this big giant pen full of sheep. And the entire thing is divided up into 45 smaller pens, 15 of which are full of red colored sheep, and 30 of them have uncolored white sheep. So this is representative of the fraction 15 over 45. 15 of the total 45 sheep are colored red. Now I'm going to look at what happens if instead of 15 out of 45, we divide the pen up into 3 pens with the same amount of sheep and the same amount colored. We can see here that the sheep perfectly match up from the 15 red pens into one giant red pen, and there's no sheep left over or anything. And over here, we've got exactly 2 pens of white sheep, because there's twice as many white sheep here as there are red sheep. So we can clearly see that 15 over 45 is really just the same number as 1 over 3. So what we say is 30 over 45, 30 45ths, can be reduced by a factor of 15. That is, 30 reduces by a factor of 15 to 2. 2 times 15 is 30. And 45 reduces by a factor of 15 to 3. 3 times 15 is 45. Whenever you reduce fractions, you've got to remember that you reduce both the numerator and denominator by the same factor to get your final result. And this is our final result. 2/3 doesn't reduce any simpler. Also, in the case that the numerator is larger than the denominator, like in 45 over 30, for example, we must take out the whole number portion out of the fraction to make it a mixed number. So 45, one lot of 30 can be taken out of that. If we do 2, that would be 60, which is too much. And we end up with 1 and 15 over 30. As a review, we can reduce 30 over 45 down by that factor of 15. How we find that factor of 15, it's the greatest common factor between the numerator and denominator. So the greatest common factor between 30 and 45, which you might remember to find, you can just make a factor tree of 30 and 45. So 30 is divisible by 6 and 5, which are then divisible by 2 and 3 in the case of 6, and 5 is prime. So 2, 3, and 5 make 30. 45 is made out of 5 and 9. And 9 is made out of 2 lots of 3. So the greatest common factor between these two, the common factors are 3 and 5. So the greatest common factor is the product of those. 3 times 5 is 15. That's how we got our reduction factor of 15. But that's kind of a lot of work just to reduce a fraction down. So what I'd recommend doing instead is just reducing it one step at a time. So here, you might not know that 15 over 30, 15 goes into 30 twice. Let's say you do know, however, they both end in either a 5 or a 0, so it'll reduce down by a factor of 5. 15 reduced by 5 is 3. 30 reduced by 5 is 6. And then from here, we know 3/6 is 1/2. And that's our final reduced form of this mixed number. Back to our original problem of 3/5 times 10/9, you might have noticed that the second number we have here is an improper fraction. And we actually want that. Whenever we multiply two fractions together, we want both of them to be improper fractions, so we can easily just multiply the numbers across. Then from there, we can convert them back into proper fractions and reduce them down and all that. Let's look at an example of multiplying two mixed numbers together. Another way to think of 1 and 3/5 is 1 plus 3/5. And then we can think of 1 plus 3/5 as 5/5 plus 3/5. And if we add across, 5 plus 3 equals 8. We keep the common denominator. And our final improper fraction is 8 over 5. A quicker way to do this is if we just took the 5 at the beginning, the denominator, do the denominator times the whole number portion plus the numerator. 5 times 1 plus 3 in this little triangle motion. So 5 times 1 is 5, plus 3 is 8. So at the end, we end up with 8 in the numerator. Denominator stays the same, 8/5. Now that we've reviewed how to convert proper fractions into improper ones, let's see what division looks like. To do fractional division, I'm actually going to go back to the sheet before to help us demonstrate. Here I've got 3 sheep from the pen that we were at before. I just put them in the smaller pen to help us demonstrate how to do fractional division. In this chest, I have 3 name tags: Dave, Jeb underscore, and Dinnerbone. Let's see what each of them does. So Dave does absolutely nothing. It just kept the sheep the same. Jeb underscore, on the other hand, turns it into a rainbow sheep. Now the sheep is constantly changing color. And finally, Dinnerbone flips the sheep right around. Now let's apply this to fractional division. So to do this division problem here, we're going to follow what the sheep did. We're going to keep the first one the same, just how the first sheep, Dave, didn't change. We're going to change the division sign into a multiplication sign, just like how we changed the second sheep with the Chip underscore name tag into a rainbow sheep that's constantly changing. So there we are, division changed into multiplication. And 3 over 1, we're going to flip that right around. Put the denominator into the numerator and the numerator from before where the denominator is. And there we are. We just changed our division problem into a multiplication problem, and we already know how to multiply fractions together. So this is just easy peasy. 1 times 1 is 1, and 7 times 3 is 21. So our answer is 1 over 21. 1/7 divided by 3 is 1 over 21. we're going to keep, change, flip. And that's the mantra we'll be using. Keep, change, flip. That's how you do fractional division. You change it into multiplication. But how does that work exactly? How can we possibly change a division problem into multiplication? Aren't those things like opposites? Let's look at a simpler problem to try to get a better understanding of how this whole process actually works. Now, you should just be able to do this simple division problem right in your head, but we're not going to. We're going to try to change this into a fractional division problem. So to turn 6 into a fraction, we're going to change it into 6 over 1, and to change 3 into a fraction, we'll do 3 over 1. Now that we have this as a fractional division problem, let's see what happens when we apply keep, change, flip to it. So we'll keep the 6 over 1 as 6 over 1, change the division into multiplication, and then flip the 3 over 1. Now it's just 1/3. We just changed dividing 6 by 3 into multiplying 6 by 1/3, which you might realize is the exact same thing. We're just taking 1/3 of 6. You might recall that a fraction is kind of like the numerator is being divided by the denominator. And when we flip the second fraction over, all of a sudden, now we're multiplying by what used to be the denominator and dividing by what used to be the numerator. And that turns our division problem into a multiplication problem. That's what makes this simple trick work. Keep, change, flip. Flipping the numerator and denominator to turn our division problem into a multiplication problem.